Good morning. Today we are going to be applying the properties of logarithms to condense and expand logarithm expressions. And on the next few lessons, we are going to use those three properties to solve equations that involve logarithms. Let's look at the three properties of logs. We have the product property, we have the quotient property, and the power property. Now, if you guys remember from the last lesson, we know the logs and exponents are very closely related. They're basically the inverse of each other. So the same way that if we have x to the second power multiply product by x to the third power, we can just add the exponent. So this will be x to the fifth power. In the same way, if they're multiplying, we have the log base b of two numbers or two variables. We can rewrite it as two separate logs. One log base b of u, log base b of v, and there's a plus in between because we add the exponents. In the same way, if you have a division, we can subtract the exponents, so this will be 5 minus 2 is equal to 3. So we can rewrite or expand with two logs, base b, the same base, and there'll be a minus in between. Log base b of u minus log base b of v. The power property tells you if we have an exponent, we can go and place it on the front as a coefficient. So log base b of u to the n power is equal to n multiplied by the log base b of u. We are going to be using those three properties to expand and condense expressions. So let's go over problem number 1. I want to be able to expand the expressions. One of the things that you need to be aware is that we have how many terms do we have in here? We have one term, and how many components? We have the 3 and the x squared. So once we are done, we should end up with two logs. They are multiplying, so we are going to use the product property. We are going to be using the product property to simplify it. We're going to have the log of 3. We're going to have the log of x squared. Because they are multiplying, there'll be a plus in between. Now, we have an exponent, therefore we're going to use the power property. So we're going to place the exponent for the x as the coefficient. This will be the log of 3 plus 2 log of x. And that's it, we expanded it. Let's look at example B. We have the log base 5 of 2x to the fifth divided by y to the second. Let's go and see how many components do we have for the log. We have the 2, the x, and the y. So we should end up with 3 logs as our answer. We have the log base 5. Notice that the base stays there. The first component is 2. We have the log base 5 of x to the fifth power and the log base 5 of y squared. Now, the 2 and the x to the fifth are multiplying, so there'll be a plus in between. The y squared is dividing, so there'll be a minus in between. Now I'm going to use the power property to be able to bring the exponents as coefficients. We all have log base 5 of 2 plus 5, that was the exponent, the log base 5 of x minus 2, that was the exponent, log base 5 of y. And that'll be my answer. Go and try letters C and D by yourself, see what you get, and then we can compare answers. Go and pause it. Great. So for example number 1C, let's go and count how many components do we have. We have the 2, the x, and the y, so we should end up with 3 logs. In this case it's ln, so the natural log. So the natural log of 2, the natural log of x, and the natural log of y to the 5th. They are all multiplying, so there'll be a plus in between. The only thing that we have to do next is to be able to bring the exponent as a coefficient. We end up with the natural log of 2 plus the natural log of x plus the 5 is the coefficient now, it was the exponent before, and the natural log of y. And this will be your answer. For letter D, let's go and think, how many components do we have? We have 1, 2, so we should end up with 2 logs. They're multiplying, so there should be a plus in between. We'll have the log base 8 of 64 and the log base 8 of x to the 2nd power. They're multiplying, so there'll be a plus in between. Now we're going to use the power property to be able to bring the exponent as a coefficient. Now you should also notice that this is an 8 and this is a 64. So just like we learned on the last lesson, we can rewrite the 64 as 8 squared. So that way we can simplify this. Log base 8 of 8 to the what power 64? To the 2nd. Because this will cancel out, and this will be equal to 2. But let's continue. Plus 2, the log base 8 of x. Let's go and bring this down. Plus 2 log base 8 of x. Remember that if you are able to simplify the log, you want to be able to simplify all the way through, just like we did on this problem. Let's continue to example number 2. On example number 2, we want to be able to expand the following expressions. We're going to work backwards. We want to be able to bring the coefficients as the exponents. Therefore, we have the log base 4 of x to the 7th power. It used to be the coefficient, but because of the power property, we can place as an exponent, plus the log base 4 of y to the 5th power. It used to be a coefficient, now it becomes an exponent. Now we're going to use the product property, because there's a plus, we're going to, and they have the same base for the logs, we're going to rewrite it as 1, the log base 4, and this will be x to the 7th multiplied by y to the 5th. Letter B. We are going to go through the same process. We're going to bring the coefficients as exponents, the coefficients as exponents, the coefficients as exponents. So let's go and rewrite it. We have the natural log of 9 to the power of 1/2 plus the natural log of x to the 2nd power minus the natural log of y to the 3rd power. Now, I want to be able to simplify this, but you want to be able to remember the 9 to the 1/2. Do you remember what 9 to the 1/2 is? No, it's not 4.5. 9 to the 1/2 is the same thing as the square root of 9. And the square of 9 is equal to 3. Let me rewrite this. So if you are able to simplify, you want to be able to simplify before you combine it into one log. Now let's combine it into one log. The natural log, this are adding, so we're going to multiply 3x squared. There's a minus in between, so there'll be a division, y to the third power. Remember, if there's a plus in between, they'll be multiplying. If there's a minus, there'll be a division. Go and try example C and D and see what you get. Go and pause it. Great. So for letter C, we have 3 logs. We're first going to place the power property. We're going to place the coefficient as the exponent. And there's no coefficient here. So this will be just the natural log of 18 plus the natural log of 1/3 to the second power plus the natural log of x. Now 1/3 to the second power can be simplified. 1/3 to the second power is 1/3 times 1/3, which is 1/9. Now we have 3 logs, they all are adding, so we're going to combine it into one log, and they're going to be multiplying. There'll be 18 times 1/9 times, oh, and I forgot to write down the 3, x to the third power. You can simplify this if you want to place it over 1 and just multiply the fractions. So it'll be 18 over 9. The natural log of 18 over 9, which is equal to 2x to the third power. Now on the last one, same process. We want to be able to place the coefficients as exponents. Coefficients as exponents. This will be the log base 5 of x squared minus the log base 5 of y to the third power. We have 2 logs, base 5, they have the same base. There's a minus in between, so we're going to condense it into one log, base 5. And this will be x squared divided by y to the third. There's a minus in between, so there will be a division in between.